Okay, here's just a little precursor to looking at transformations. So the question says, what position is the number 2 in the following function? That's that one right there. So I look here at this function. This is, I guess it's not a function, it's a general form for a function where this f can be anything. It could be a sine, it could be a cos, it could be an exponential function, a log function, a quadratic function, doesn't matter. It could be any of those. So like if I'm looking at the sine function, if I want to put a sine in where that is, I could go a and then sine and b x minus c over b plus d. So if I want to know what position that is, it's in front of the function. So the thing that's in front of the function is an a. So that 2 is in the a spot. And that'll tell me something about the function. It's the vertical stretch transformation. So whatever a is does a vertical stretch. Or it'll do a vertical squish as well. Here's another one. So they say, what position is that one? Again, this is a quadratic function. So the quadratic function looks similar to the one that we had with a slight variation. So it would be like f of x is equal to a exponential. So it would be, how would I write that? B x minus c over b squared plus d, something like that. Yeah, something like that. And so they want to know what position is the 2 in. Well, when I look at this, what position would that 2 be in? Notice it's adding at the very end, and that's what that one's doing. So that 2 there has to be the one adding at the end. It's got to be in the D spot. Again, notice like this one, I could have written it, say, like a log function. I could have said a log b x minus c over b plus d, and it doesn't matter what function it is. The thing that's being added at the end is always in the D spot. Let's look at the last one. What effect does the number 2 have on this function? So, and we went through this in the video, but let me write out our whole function again. This is a quadratic one, so a and then bracket b x minus c over b squared plus d. So they want to know, it's in brackets and it's multiplying the x. So it's inside these brackets and it's multiplying the x. So that must be this one here, b. So we want to be looking at b. In the video, I showed what each of those things do, but b specifically is a horizontal stretch or squish. Now this one, no, and B and C are, B and C are the same kind of thing that they deal with x values. So left, right, squish horizontally or stretch horizontally. But they're opposite to what you think. So if B is greater than 1, so if it's bigger than 1, then it's going to be a squish. But if b is in between 0 and 1, then it's a stretch. Sort of opposite what you'd think. Like if you think the bigger the number, the more spread out it gets, and it doesn't do that horizontally. The bigger the b number, the squishier it gets. And so this one says, what does 2 do? And it's going to be a horizontal thing, so it's not vertical. And since it's greater than 1, then this is going to be a squish, horizontal squish. And we can just show that. I'll show you a good example of that happening. And I'm going to just use a sine one because that you can see it the best with that. So y equals sine, where's my sine? Right there, sine of x. There's my sine of x right there. Let me zoom out a little bit. Perfect. Now watch what happens when I put a number in front of the x in the b position. So if, say I put a 2 there, well, let me make a new one. Sorry, just so you can compare. y equals sine x. Oh, I want to put a number in front of the x. So if I put a number in front of the x, if it's larger than 1, that graph is going to squish. Well, I'll put a 2 there. See how the blue one is squished? Sort of like a slinky, it got squished. If I put a 20 in there, it gets even more squished. That's a little extreme. If I put a number in between 0 and 1, like a half, so let's put 0.5 in there, see how it elongates? So now the blue one is longer than the red one. Okay, so that's the effect of B. Hopefully that helps. In class, we'll go over more of these and do some examples.